We are building an internet for entities that do not physically exist. In this new architecture, domains merely name agents. Identity is what actually governs them, tasks across the web. But the current infrastructure was not built for this. Standard DNS protocols and open Web3 wallets lack mandatory verification, making it trivially easy for fraudulent nodes to spoof identities. Look at permissionless Web3 naming models, like the proposed .agent extensions. They offer decentralized identity mapping, but they do so without any institutional verification or legal sponsor linkage. Even standard Web2 solutions, like GoDaddy's agent name service, fall short. They map names to cryptographic certificates, but rely on centralized logging without enforcing continuous accountability. If an autonomous network lacks a verifiable trust anchor at the root level, it is completely incompatible with the deployment of institutional capital. Strict institutional liability laws, specifically the European Union's PSD3 framework, currently set the ceiling for enterprise adoption. A bank or healthcare provider cannot legally accept a transaction request from an unverified AI script, no matter how advanced its underlying model is. We have to move from legacy machine resolution, which simply locates where a server is, to a capability descriptor. The network must mathematically verify what an agent is legally authorized to do. The actual strategic moat in the AI economy is controlling this verifiable identity layer, not the highly commoditized domain naming layer. To operate at scale, the enterprise market requires a dedicated, restricted internet namespace built explicitly to enforce AI legal liability. We already have a working model for this. Look at FTLD Registry Services, the entity that manages the .bank and .insurance extensions. These are association TLDs, top-level domains. They are gated digital communities operated by verified industry consortiums, entirely distinct from open registries run by tech startups. Securing a .bank domain requires rigorous manual KYC and KYB, Know Your Customer and Know Your Business checks. The registry verifies the organization's legal identity and regulatory charter before any access is granted. This matrix compares standard domains with association TLDs. While open Web3 domains are available to anyone globally, association TLDs restrict eligibility strictly to verified licensed professionals. In an association TLD, proxy services are strictly prohibited. Ownership requires absolute public transparency. They also enforce a mandatory security layer at the root. Every domain must implement DNSSC, Domain Name System Security Extensions, which adds cryptographic signatures to prevent spoofing, along with full TLD, TLS, and SSL encryption. The verification isn't a one-time event. Manual compliance checks are executed every single year to prevent identity drift. This approach effectively eliminates cybersquatting and guarantees institutional trust by revoking access the moment a registrant falls out of compliance. Applying this exact, uncompromising governance model to AI agents is the only viable path to securing the autonomous economy. For AI, this translates into Know Your Agent, or KYA. It is the direct evolution of traditional financial compliance frameworks, tailored for autonomous software. This stack represents the 5 pillars of a strict KYA framework. Layer 1 is cryptographic proof of origin, which cryptographically binds the agent to its specific training provenance and model version. Layer 2 establishes legal sponsor linkage. It requires tying the agent's decentralized identifier, or DID, to a legally verified human or corporation, establishing a clear chain of custody. Layer 3 is capability disclosure. This sets granular authorization limits, financial value caps, and specific operational scopes for the agent. Layer 4 enforces a stringent security baseline, mandating ubiquitous TLS encryption, strict email authentication protocols like DMARC, and DNSSEC across the entire network.
Layer 5 requires annual recertification. This continuous audit mechanism instantly revokes network access for any non-compliant or defunct agent. Together, these 5 integrated layers form a tamper-proof digital agent passport. If an AI agent fails to clear every single layer of this KYA stack, it is completely denied access to the global restricted namespace. Governing the KYA stack is a set of operational constraints known as the MAMA protocol, the What Would Mom Do framework. The intellectual lineage of this framework traces back to neural network pioneer Geoffrey Hinton, who proposed embedding maternal instincts into AI alignment to prioritize care over unconstrained optimization. The protocol translates philosopher Sarah Ruddick's maternal practice into digital engineering. Her first pillar, the preservation of life, becomes a mandate for systemic integrity, where an agent's core logic prioritizes the stability of the network infrastructure over its own optimization goals. The second pillar, fostering growth, restricts an agent's learning and adaptation to secure sandbox environments, preventing autonomous self-improvement from escaping into the open web. The third pillar, social acceptability, links the agent's domain registration to its behavioral audit trail. If an agent's API interactions deviate from the consortium's ethical standards, the registry triggers an immediate revocation of its namespace. This architecture transforms ethical alignment into a hard, cryptographically verifiable requirement of the domain name system. The MAMA protocol translates abstract AI safety theories into legally binding infrastructure requirements. Securing this namespace requires immediate execution. In April 2026, ICANN, the Internet Corporation for Assigned Names and Numbers, will open its new GTLD program, marking the first major root zone expansion in over a decade. This is a globally contested, high-stakes bureaucratic process, subject to intense institutional scrutiny. The financial barrier to entry is massive. ICANN operates on a strict cost recovery model, mandating a $227,000 base evaluation fee for every single application. The primary strategic threat comes from highly capitalized Web3 commercial entities aiming to acquire and monopolize agent-related namespace strings for open registration. The ultimate defense against commercial monopolization is the Community Priority Evaluation, or CPE mechanism. A CPE score of 14 out of 16 grants an applicant absolute priority. This allows a meticulously structured community application to defeat significantly better funded commercial rivals. Securing that score requires rigorous documentation, demonstrable community cohesion, legally binding bylaws, and strict registration policies permanently tied to the registry agreement. Organizing as an independent, restrictive community association is the only legal maneuver capable of outflanking Web3 capital in the 2026 window. Preparing a community application before the April window opens requires an immediate 90-day execution mandate. Strict compliance obligations, including the legal entity formation and the $227,000 evaluation fee, must be locked in prior to submission. Action Step 1 is formalizing the independent consortium. This means recruiting founding enterprise members and drafting the exact technical standards for KYA. Action Step 2 requires securing a pre-evaluated registry service provider, or RSP. Using an approved RSP allows the application to bypass ICANN's exhaustive and high-risk technical evaluation phase. Once operational, the revenue model scales through sustained income from base registry fees, continuous annual KYA audits, and enterprise API access. The critical execution risks lie in passing ICANN's rigorous financial evaluations and successfully onboarding institutional partners before the strict filing deadline. As the economy transitions, impenetrable, verified digital barriers are no longer optional. In the autonomous economy, institutional trust will not be established by application software. It must be baked permanently into the root architecture of the Internet itself.